My name is Jeannie Morris, and this is my Exercise 7 presentation. And we were asked to use the employee attrition dataset and build a logistic regression model to predict employee attrition. I have went ahead and done this. However, when looking at the model, there is a very small R squared. So that tells us that the model is not doing a good job at predicting employee attrition, and only 7% of this can be used. It also asks us to determine what the model equation is. So if we maximize this, we can go to our parameter estimates. And I went ahead and wrote out the model equation here. So you're going to start off with taking the intercept, the 2.19, and then it'll be minus the 0.25 times work-life balance, minus 0.11 times the years at the company, minus the 0.27 times job satisfaction, plus 0.12 times years since last promotion, minus 0.27 times environment satisfaction, minus the 0.04 times age, and then plus the 0.03 times distance from home. And I did go ahead and round these numbers. If you were to use these full values, you would get a more accurate answer. So we'll go back out of this. And again, like I said, the model does not seem to be performing well. However, if we mess with our roles, so let's say instead of making the response or the prediction our attrition, let's do years at the company, because that's along the same lines, like how are these different variables affecting how long employees stay. So it won't let us do years at the company, that's fine. Let's do job satisfaction, and that won't work either. Let's remove attrition. And we'll do let's just test it out with job role and see how our R squared changes, and it is still very low. Maybe we'll do education field just to try some different things out, see what might be a better, and that R squared is very small. So attrition seems to be the best fit here, but again, this model is just not doing a good job of predicting the employee attrition number. We could try taking some of these out and see if that will help. So our lowest one is going to be work-life balance. And then environments, distance from home is next. And we see that actually after removing those, the model became even less accurate. So overall, I would just say this is not a good model to use. So now we're going to see if we would get the same results using a GLM. So I'm going to unmaximize this, click on this box, and just change our model over to the GLM model. And this gives us the ASC. Let me go back and duplicate it first just so we can compare. Okay. Alright, so here's our logistic regression model, which is what we started with, and then we have the generalized linear model. So let's look at our ASE because the GLM does not give us an R squared, and the logistic regression does not give us an ASE. So let's try and find something that is similar that we can compare against. So here the AIC for logistic regression is 1,211. And for the generalized linear model, it is 8,704. So these are not giving the same results when converted over from a logistic regression to the generalized linear model, which may just be because this is more generalized. It also asks us about outliers, which we are seeing quite a few of. So if we want to remove these, we can do it in one go and just highlight them. And then we're going to new filter from selection, and we're going to exclude the selection that we highlighted. And then we're going to go back to our R squared and just see if this has made a difference. And again, like we were experiencing with changing the roles around a bit, the R squared actually declined. So it does not look like removing the outliers made it any better. We'll exclude a few more outliers just to see. So those outliers actually led it to be bigger. And increased a bit. So if you play around with it a little bit and can figure out which outliers do need to be deleted, this model might be accurate. But again, this is still a very small R squared, so I would say that it's not a good model to use. Next, we were asked to go to our look at what we did in chapter 6. So I went ahead and pulled up my exercise 6 SAS-Viya page that I had saved. And it asks us to create a house price regression model, which I have done here. If we go to our roles, we'll see that the sales is what we're trying to predict, and our continuous effects, what we're using to predict these, is the TV, radio, and press. I did have one house price page, just going back to prior, because it did ask us to use house price, but the house price page I have only had kitchen quality and then sales price as the predictor, which would not make it a multiple regression. So I felt this would be a better example to use. So going back to that, it then asks us to use this to make the GLM, generalized linear model, which I did do. And it's funny because in this model, we actually do have the same results going from the linear regression to the generalized linear model, which may be because they're both linear models rather than one being linear and one being logistic. We're also asked to make sure that within this generalized linear model that there is a normal distribution, and the link function is set to identity. So we're going to go to options, and let's see here. No, it's under general. Here we have normal distribution, and the identity link, or the link function, is set to identity. And this concludes my presentation. If you have any questions, feel free to reach out. Have a good day.